I think, to maybe just one more answer to Molly. Our idea with Be Smart is the economics are actually there to make this a good deal for the utility to really install these things in everybody's homes. They can make it work because they control the rates. They get the margin. They collect the margin on the additional electricity. So, they're setting their rates at 28 cents per kilowatt hour because PG&E's rates are there, but their cost is less than that. They've got some margin to work with. So economically, it makes sense long term to do this. So if we can get those utilities to say, hey, this is your business long term, and we can say, oh, well, that means we can put together a program that's basically bill neutral for a customer, and they get all these health benefits. Yeah, we'll pass a gas ban. We won't let gas devices anymore because you've kind of covered us from the economic hardship that might otherwise create. So I think if we can create these programs that are easy, then we can say to city councils, yes, you're okay if you pass this ban right now. You're not going to get this, political resistance, which is all around cost and equity right now. That's what's holding us back. It's not the underlying economics or the technology. It's just this political will to do.
Thank you. Terry.
I have a question, yes. Are there electric furnaces that are compatible with an Eichler's radiant heating system, or would electrifying involve adding ductwork?
There are air to water heat pumps that would work with an Eichler's water radiant, hydronic floor system.
Cool.
So one brand is Chilltrix, and I think another is Arctic, but they're in the guide. I forgot what page they're on, but if you download from that link I put in the chat, the guide, you'll find air to water heat pumps that'll work on hydronic heating.
Thank you.
I will add to that because I was in a WebEx where there were people presenting about going through that process, and in an Eichler they were saying, well, we looked at the alternative of mini splits to just trying to get a heat pump to do our hydronic heating, and it's just the mini splits were cheaper and ended up more comfortable for their home. So they just left the hydronic and kind of abandoned that and used the heat pumps, or they kept it running, but it never went on because the mini splits took care of the heating,
right,
and addressed their issue.
Right. Yeah, I was in that webinar too. That was a smart way to do it. Because Eichlers are so open, one head from a mini split can spread its heat widely throughout the Eichler. And so you can start with this experiment like the gentleman did. He put in one head mini split and he liked it. And when I heard it, I thought, oh, I'd put another one back in the hall closet, or not hall closet, in the hallway, back where it was hard to reach to heat the bedrooms. So yeah, they're doable, and you can just, for those ones, you could put the outdoor unit on the roof or on the ground and just poke right through the Eichler deck roofing to run the line set. It's only a 2 or 3 inch diameter insulated tube.
Thank you.
Okay. Do we have any other? I have a question or two, but I'll hold off. Anybody else have a question?
Well, I had another question.
Okay.
Where is there a bigger bang for the buck in getting people to buy electric cars or getting people to buy heat pumps? Because right now we're paying what, $8,000-$10,000 to get people to buy an electric car, and we're not paying people to buy heat pumps. I mean, heat pump water heaters, but not air heat pumps. Would it make sense to transfer some of that money that we're paying on cars over to heat pumps if that would incentivize people to install them?
I think that might be good policy because it looks like the electric vehicle market is taking off on its own. I think we have launched that rocket, and especially with the governor's order that there won't be sale of new gasoline cars past 2035. We need to now try to launch the heat pump rocket and maybe apply some incentives over on that side. So I like your idea of trying to see what is the the reasonable rebate. And then I wanted to tag on to something Bret raised about the net revenue produced for CCEs, community choice energy groups, from electrification. And it's kind of interesting. I did an analysis of heat pump water heaters. Each one that gets put in over its 12 or 13-year life would generate about $400 of net revenue for the CCE. So that's kind of the long run amount of rebate they need to offer to be fair. If they don't offer it, they're collecting too much money and they pop eventually. Their money bag pops. And if they offer more than that, then they deplete the total money bag and it eventually goes away. So long run, about a $400 incentive needs to be deployed back out by the CCEs. It's different for SMUD, who's a vertically integrated utility who gets transmission and distribution revenue. And so they have to deploy more money, otherwise they'll pop.
I had somebody tell me they put in a solar system and they were prohibited from putting a heat pump water heater for their pool. Is that true? And what is the rationale that they would ask that? Because it seems like a heat pump water heater could be operated during the day, could sop up all that extra, net energy.
Yep, Ken, I think
it's
it
the exact
relates
opposite of what should be done.
Right. But again, Ken, it relates to that same thing you pointed out earlier. We have rules that are way behind where they need to be. And so the prohibition in California on electric pool heating used to be the policy, and it is
made
now
sense 10 years ago.
Right. It made sense back when the grid was dirty and we were ignorant about gas, so we thought gas was clean. And now we are understanding gas is dirty, gas is the problem. I have a saying, methane has a plan for Earth and it's Venus. So once there's enough methane in the atmosphere, it will free the sleeper cells in the tundra and they'll all go up to the atmosphere together to dominate us, and we will be Venus. But yeah, so policies are, they need to be updated for where the science has gotten us and the technology. And now it is legal to do heat pump pool heating. And
So it is.
Yeah, oh yeah. And in Menlo Park, it's required in pools for new buildings.
Okay.
You can't put in a gas-fired new buildings pool in Menlo Park anymore.
Okay.
Well, thanks, Tom. I think one of the things I think the regulators are going to have to become is more agile, because on the other side of what's going on is huge potential of offshore wind from the West Coast, particularly around California. And that will run at night. So we may see some of these optimal solutions shift as we get wind renewable, even on ground. It's still a night source. There isn't that much of it on our state.
Right. You're right, Gary. We do need to be nimble. And as a electric utility planner, when solar was coming on, I really underestimated how fast solar would come on in California. And so in Palo Alto, I think we overvalued our solar contracts and we undervalued our wind contracts. And I started noticing that shift, and I told my mentees who I'd trained, redo those calculations, switch direction quick.
I don't feel embarrassed by making that judgment, because I've heard professors from Stanford say, I never thought that would get that low.
Yeah.
I mean, it is, you don't know. I mean, a lot of people will argue about nuclear and stuff. Unless you really pursue something, you don't know what you can get out of it. And as a market expands, more people are interested, more money's invested. So cost parameters can change drastically. And that's what's happened with electric cars. I mean, Tesla didn't make any money on the first Model S.
Gary, I'm going to have to sign off. I have to prepare for another meeting, if you can believe it. But
Okay, well, thank you very much, Bret. And I think this.
Yeah, I hope it was useful. It was a pleasure
Yeah.
Very
to
good.
talk to the group. Thanks for inviting
Now,
me.
are we going to get a chance to look at some of the material that you presented, or are you going to set? Is that available at a website, or can you send it to us via email or something of that nature?
You can get like our full Be Smart presentation, which this was just a subset, on carbonfreepaloalto.org. So if you go to our URL for Carbon Free Palo Alto, you'll see a PDF version of our presentation. You can just, definitely flip through that and use it as you like.
Is that .org? CarbonFreePaloAlto.org.
Yeah.
Okay.
Or just search Carbon Free Palo Alto and the website will come up.
Well, I noticed in the chat, Tom's put up the retrofit guide, so everybody can download the file if they want, or just click on that. And you put Casio. We got another one for Casio.
Yeah, I put
Yeah,
up the
here.
KAISO site because it sounds like Ken and I both really enjoy watching what goes on the grid. And that site is
I
fun.
take a look at the duck curve all the time, and I think
Same
it's
here.
interesting.
I know. It's like every night before I go to bed, I like to see, what was yesterday's resource mix like.
All right. So I put the page in with our presentation in the
Okay.
chat, just for the record there. And
Okay.
So
in case anybody has a problem finding it.
I'll toss the one last question. So I'm in the process, or my wife and I guess, of getting backup batteries. I say backup because she's been insistent on this. And so I've gotten some bids, whether it be one or two Tesla Power Walls. I don't know. But one of the interesting things that came out of it is one of the engineers that advised this company called Swell, SWELL, to keep the my connection to 100 amps through the circuit breaker box, that if I had 2 units, that they have some device that could actually just decide to drain the battery rather than request more current from PG&E.
Oh, nice. So then the battery would contribute to meeting the loads on the panel
Yeah,
when it senses that the panel is getting near its limit.
yeah.
Nice.
It sounded kind of tricky,
Mhm.
and the salesperson, of course, says, "Well, if on close inspection it doesn't work, we'll give you your $500 deposit back." I mean, somehow I don't like that, but
Yeah, I'd like to look into that. You say you found out about it through Swell?
yeah.
Yeah, okay. I'll try to look them up.
Yeah, well, whatever you can find out, I can show you more what I'm getting from them. So, but the batteries do provide you the ability to take whenever the peak away and then charge up, even if you don't. I have some solar, even if you don't have solar, and then discharge it. I'm sorry, charge it at night when the rates are lower.
Mhm. Oh, good.
I
Yeah,
had
I've been
a question. I've got a 1964 furnace, gas furnace, 100,000 BTU gas furnace in my house. And my understanding is that heat pumps, they require larger ducts. Is that right? In order to deliver the same amount of heat? Did I hear that right? And if so, do I need to be concerned about using my current ducts?
Yeah, so before I get into the weeds, how big is the house in square feet?
1930. And but the ducts
And that's
were put in the
so
downstairs
less than 2,000 square feet?
in 2000.
Okay.
But I should mention the downstairs only has one duct.
Mhm.
So the upstairs gets toasty warm in 5 minutes, and the downstairs is always cold.
Yeah.
And so what I was thinking of doing was putting a split system downstairs and just have it condition that area. And then the heater would primarily be responsible for the upstairs.
Yeah, and plus some heat would drift up anyway.
So heat would up anyway. Yeah.
Yeah, that sounds like a great idea. And so I like doing that kind of thing where I just experiment, and the experiments are relatively low cost, especially if you use the little do-it-yourself mini split. You know, that's about $1,600 for what, just 1 ton, 12,000 BTUs per hour. It turns out, that furnace, that 100,000 BTU furnace, is way oversized for the house. And so it cranks the heat way up, and then you coast.
I did a manual J. I'm assuming I did it more or less right. And I said, I need about 50,000. I thought I would needed 50 or 60,000. But every contractor I had come in said, oh no, you need 100,000. I said, no, I don't. And he said, oh yeah,
Right.
You do.
Right. Yeah.
So
They're like,
I don't trust them.
yeah, they're like barbers. Everybody needs a haircut, no matter what you look like. So, yeah. And so, the trick with
how
heat
many
pumps,
people are depending upon the recommendations of these contractors when the contractors are wrong.
right? And they have a bias. They have 2 biases to why they're oversizing. One is they get to sell you more hardware that they mark up. And then the other is the thing is so powerful that they'll never get a complaint that it didn't do its job. But it's just yanking the temperature way up high, and then you coast for 20 minutes till it blasts it again. And
my house,
yeah,
in 10 minutes if it's not too cold.
right.
Maybe an hour.
So there's my little mini split thing, and that's just 12,000 BTUs, and my house is 2,200 square feet. And so I just run that thing, and most of the time that's all it takes to heat our house.
That's it?
Once in a while, my wife will turn on the upstairs heat pump that's only another 7,000 BTUs. So but it runs long hours, so it'll run, I'll see it running at 350 watts. It'll run that 350 watts overnight, and then I'll boost it up to almost 1,000 watts when I'm trying to raise the temperature in the morning to get up from, say, the house might have been down at 65 and I want to raise it up to 70. It'll run at 1,000 watts for a couple of hours, chasing that temperature. So it's a tortoise and the hare situation. And
Actually, it makes your home more comfortable.
It does.
And people want it to be heated up in 25 minutes, but then you have hot and cold all the time, and it's not comfortable.
Yeah, you're just running on a sawtooth then, and that is not comfortable. The beauty of the heat pump is it'll raise the temperature of everything in my room, because it'll basically keep it all at an even temperature. And so all the surfaces get up to the comfy temperature, so my body's not radiating heat back and forth with the cold walls.
Well, I think that's part of the educating of the population, that their expectations may not be appropriate for what would make them actually most comfortable.
Exactly. It was funny, even with an expert like Steve Schmidt, a friend of mine, put a heat pump in his big Los Altos home, and he's an energy efficiency expert. So like the old myths, we all turn our heat down at night to save energy, and then we crank the rocket up in the morning and quit saving energy. And Steve tried that with his heat pump on the coldest day of the year, a year ago, and the heat pump just could not catch up with his comfort need after that. And he learned the lesson: no, you don't set all the way down on these things. You learn its trajectory of recovery, and then you plan, if I really want it 70 by 7 a.m., I'm going to need it to be 69 by an hour earlier, 68 an hour before that, and there's this little path you're going to climb. So then you learn, okay, I need to not get below 64.
There was a question that I've had for a long time, because I have a gas furnace inside my home, and so it sends gas up the flue, and it brings in air from outside to replace all the gas that it expels. And a heat pump wouldn't do that, because it just sends things around in a circle.
Right.
And so when you hear about the different inefficiency, does it take into account that people who have furnaces inside the house actually save even more with a heat pump?
No, good point. You know, it doesn't. These coefficient of performance advantages don't account for what you're mentioning, which is makeup air infiltration. You know, that the furnace is burning makeup air and that it needs to leak into the house, and that came in cold from the outside. So
That
that's,
might save even more.
yep. And then the other thing, the other leak we can reduce is, you know, I keep talking about these different dryers, the heat pump dryer, the condensing dryer, and my combined washer dryer machine. All three of those are ventless. So they don't have that vent going out for the dryer. So that's one more, you know, place that doesn't have to leak anymore.
Are you happy with, because I've heard about the heat pump dryers and I hear they're small, they take forever. Are you happy with the performance of your heat pump dryer?
No, it's still hypothetical at my house, and we are because of that debate. And so the one I'm looking at is 4.3 cubic feet, which is about it's the size of the bigger washing machines, but our American dryers are even bigger than that. So the load that goes into the 4.3 cubic foot washer then goes into a 7 cubic foot American dryer. So there is that little
Oh.
debate at my house about that. My friend Josie in Menlo Park, a fellow commissioner, she got a hybrid heat pump electric resistance dryer that's 7.3 cubic feet. So it's big American sized, has a heat pump and a resistor. So she can cook her clothes after she's dried them.
Well,
Oh, okay.
Tom knows Indra Deep. So he warned me about heat pump dryers